Hello. Let's have a look of the Lab 6 tonight. Let me open the page. In this lab, we are required to do some coding at the first question, exercise 1 here. So we are going to use the network simulator to build this kind of network to simulate this kind of scenario. And they have already gave us a template. So just simply click this link, and try to download it. I will open my VLab. Give me a sec. Okay, so I have opened my VLab and we log into the web CMS and go to the question here. So they have already gave us a template. Simply download it. And yes, and let's have a look if we can run it. Where's my file? Exercise 2. NS exercise. And see, it has syntax error, so we can't run it before we modify it. So we just simply open it with the GEDIT or whatever you want. So you can see this one, then you need to learn a little bit about the network simulator syntax. Here you can see this one. We need to fill this area. So what can we do? You can find all the content have this symbol. So you can see we need to fill this lots of lines. So yeah, let's try to do it now. If you have no idea how to do it, just have a simply look of the example here. So we don't even need to go to the website to check the syntax because they have already gave us some example here. So we are going to like fill some stuff here and finally achieve this kind of structure. Okay, let's see, what should we do? Here, open the name trace file. Set F1, open. Yeah, and here you just simply copy this line. Set F2. Right? Because we have two TCP overflow, right? So here, the first content and create a node. I will create, just simply copy the example here and change the name of it. Node 1, node 3, node 2, node 3. And yeah, you can do the remaining, but I will not finish it. You have the idea, what should we do now? Just simply follow the example here and create the links between the nodes. So what can we do? Create the links. And see, this one is the link from node 2 to node 4. Right? And yeah, oh, sorry, it's here. So create the links between the nodes. It's here. So we need to simulate this one. Had a look of the picture at first. This one, this picture. We need to write it according to this map. So 0 to 1 is 10 Mbps. Is that correct? 0 to 1, 10 Mbps and 10 ms dropped out. Okay, so in here, we just copy the line here, create the links, and from node 1 to node 2 should be node 1 to node 2, 2.5 Mbps and 40, and keep copy the line, and node 1 to node 6 it's 2.5, 40, like this. And you need to keep going like this. Just have a look of the map and fill the content like this. Is that okay? And then set the correct orientation for all nodes. It says N1, N2, N1 orient right. Also, it's for the orientation. If you didn't set it, I think it's okay. Yeah, but the map will look different if you didn't set it. So you just need to copy this line. If you didn't fill this area, the script can also run, but yeah, the map will look different. So we can see the node 6 is on the right hand side of node 1, orient right. And then do the same thing to the 6 and 7. And how about up and top? Up and bottom, sorry. Let's do the N1 and N2. So N1 and N2, what is the orient? It's up. Does it make sense? The 4, 6, then you have the idea. This, what should be this one? Should be 6, right? And this one should be 4. And you should also do the thing for the 3, node 2, 3, 4, 5 here. Just simply copy this kind of format and keep going. Let's see what's next. And here we got more examples about the queue limit and the TCP connection, because we want to know what kind of traffic do we want to set up. For example, in here, node 0 is attached with the TCP link 1. So we can say that node 0 create a TCP link. Let's call it TCP1. And connect to which one? We didn't say it. This one, number 5. So it connect to node 5 here. So now we know there is a TCP connection from node 5 to node 0. So you understand this one and this one. So in this area, we just simply do the same thing as I just changed the name of it, create a TCP agent and attach it to node 3. So copy this line, paste. In here, because we are setting a new TCP link, so we give it a new name by as TCP2 or 3 or whatever you want, and attach to node 3, right? Node 3, and attach with the name of TCP2. So that's how we attach it. So you can see we have example here. So the syntax will not be a problem. We just need to have a look and understand it. And the other stuff, sync to the traffic. So the same thing. Just copy this one and check if we need to change anything. Do we need to change? Let me check. Should be okay. Set sync. Probably set another name for the sync. And yeah, sync for traffic node 5 and sync 2. Yeah, this one should be okay. And then keep going, connect. Just copy this one, connect. We want them to connect. So which one? The TCP2, right? So we change the name of here, TCP2, and what is the sync name? Sync2. And TCP2 set ID2. Yeah. So does it make sense? And set up the FTP over TCP connection, and yeah, simply copy it. And the TCP change your name to FTP2. And FTP2 attach agent with which one? The TCP2 here, right? So you can see this part is quite similar as the previous part, the example here. So they have already gave us an example. So what we need to do, just like copy it and change the number or change the name of them. And yeah, so you just keep do the same thing, but by changing the name and have a look of the node name here. Just be careful of the name. Make sure you have changed the right name. Yeah, so you can see that we are keeping doing the same thing by building the communication, set out the simulator. And let's come to this function. Here, what should we do? We need to claim the variable of this of here. So it's glow to save us time. I will just tell you what to do here. And as sync 1, sync 2, F1, F2, we have already created in the previous line. And we get an instance of the simulator and set a time after the calculate how many bytes have been received by the traffic. Sync at N5. So set the sync bytes. And what's the next one? So in here we just copy it here, create a new one for the sync 2. Right? Makes sense? And we keep going. What is the time and calculate the bandwidth? Because this part is for the output. We want to finish this part to generate some output we need. Okay. And reset bytes value. So we need to assign a new value to the bytes. So if you have checked the document, you say it is in this kind of syntax. Sync 1 set bytes 0, and yeah, and sync 2. So you will do the rest. Does that make sense? And here we need to know some basic syntax for NS. But in the previous part, we don't even need to have a check of it, but we just copy it and change the name of it. And that's how we modify this part. How can we do with the start recording part? The start recording and as the syntax, sorry, the syntax, it is like this. So in here, you just do the thing. You can see the record. You just change the time 2.0 FTP to start, and you should keep going because it have some description. When does it start, right? In here. You can see that at 0.5 seconds from node 0 to node 5. So it's node 0 send a message to node 5 at the time of 0.5 seconds. Yeah, and just keep doing like this. You keep doing like 3.0, and what should be the name of it? I don't know. Probably you know this. And keep doing what is the time and what is the FTP. And next part is for the stop, FTP stop session. So you can see the time here, the stop is at 8.5 here. So just simply copy this. But we need to change the value of it. 8.5, we need to stop the FTP1. And at 9.5, we need to stop the FTP2. And here, we stop. Okay, so you do the rest. And here we have already called it finished. How can we run the simulator? Do you have any idea? It's this one, run. So that's all we need for this simulator. So we are using this script to simulate this kind of scenario, this kind of structure of our network. So we have 8 nodes and then 4 connections from node 0 to 5, node 3 to 5, 7 to 0, and 7 to 3. And once we have complete this simulator, then we can run it. Oh, sorry, I missed the first part. To create a simulator object. So if you have check of the document, then you will know you need to create it like this. In here, we just want to teach you how to build a network like this. So you can create whatever kind of network structure in the future if you want with the simulator by simply using this kind of script. So please let me know if you have any problem related to the syntax. But it should be pretty easy. So let's just have a quick review of it. To create a TCP agent and attach it. So what does this mean? We want to, because we have already built this structure here, we want to create a TCP connection, let's say from N0 to N5. So what should we do? We will use this to the create agent and attach it. And then we set a sync to say we want to send from node 0 to node 5 like this. And how could they connect it? It's by using this kind of stuff. So that's how we tell the simulator we want to connect node 0 to node F with a TCP connection. And the last part is about the FTP, right? Because we want to run the FTP protocol based on the TCP. So that's the key content of our script. So please let me know if you have any doubts. If we don't, I will just simply run the example output of it. Okay, so we back to here. So once we finish the script, we just save it and run it by run the command ns exercise2.tcl. And you can see the simulator here. That's our script. And we click this button, play forward. And you can set the speed. You can see how they communicate with each other. And change the speed. Okay, so what's the next step? Let's have a look. Next step is to submit your TCL file and the script throughput.plot. So we need to download the stuff, I guess. Yeah, I think it's this one. We don't. And answer the question here. So you need to write a report about this kind of question. So why the throughput achieved by flow TCP2 is higher than TCP1? Just check. Let me copy the link. Yep. So we answer this question based on the picture here. As you can see here, we had a TCP connection 1 at first from 0.5, I guess. We can't see its speed, but it should be start from 0.5 second according to our script. And keep going, and at the second, we had the TCP connection 2 joining to the thing in the network and compete with each other. And why the throughput achieved by flow TCP2 is higher than TCP1 at this point, 6 to 8. and we need to figure out what happened. So what is TCP1? We might need to have a check of the simulator here to have a look of it again. Be aware of which one is the TCP1. It's this one, right? And which one is the second connection? It's from 3 to 5, right? So why we find the TCP2 is quicker than TCP1? Do you have any idea?
I didn't understand that.
Sorry. So you need to analyze the link, the speed of link here. You need to have a carefully look of it. So firstly, you need to figure out what is TCP1 and what is TCP2. And then you need to have a look of the speed, the bandwidth of it, and figure out the reason why TCP2 is faster than TCP1 at this point, from second 6 to 8. Just have the look of the structure here, then I guess you know the answer. But yeah, if you don't, feel free to discuss with me. Yeah, could be. You need to, it might have other reasons. Because you need to be aware of that, how many TCP link we have in here. It's not only 2 TCP connection, right? As you can see here, this part, we had 4 TCP connection, but in this graph, we only show 2. So you need to consider the other 2. Yeah, if they are, let's say, if they are competing with each other, it will reduce its speed. Yeah, we can't see on this graph, but we should know that there are other TCP link in this graph. And yeah, they will change the speed we have. So let's go to the second question here. Why the throughput for flow TCP1 from 0.5 to 2 seconds? So why the speed is changing? Do you still remember the last lab? We are talking about the slow start AIMD. So if we had a congestion event, we will go back to 1 and start again, right? So that's what happened. This link is discovering its maximum bandwidth. Let's say bandwidth discovery. So if you don't remember this part, probably have a look of the congestion control part, or have a look of the recording of last lab and see why we had this kind of shape. And the question 3, why is the maximum throughput achieved by another flow? Minimum flow kept at around 1.5 Mbps at this point. So why? We can see the connection should be around 2.5 Mbps, right? 2.5. So why it's not 2.5 Mbps, but 1.5? Let's say the connection from node 0 to node 5, we can see the 10 Mbps should be very fast, then 2.5 should be faster. So from here to here, the bandwidth is able to reach 10 Mbps, and from node 1 to node 2 or node 6, the maximum speed will be 2.5 Mbps, and the same from node 2 to node 4 and node 6 to node 4. And from node 4 to node 5 should be 10 Mbps. So we can know from node 0 to node 5, the maximum speed should be 2.5 Mbps, right? So why in this graph, we can only reach around 1.5? And the only reason is they are competing with each other, right? Because if we don't have other TCP connection, if we don't have these three, we don't have this, and this, we only have one connection, yeah, then our bandwidth should be at around 2.5. Or even 5, because we can send in both way, right? But in here, we have other TCP connection, so the speed reduced, but you need to analyze why they can only achieve 1.5, even at this point, because we know at the time of 0.5 seconds to 2 seconds, there are only one TCP connection, which means in this part, sorry, it's too bad. Like in this part, there are only one TCP connection, but why it can only reach at most 1.4 here? You need to explain the reason here. We have only one TCP connection in this part. But why we can't reach our maximum speed in theory? Should be, the maximum speed should be 2.5 Mbps, right? If we go through. Here's what I found. Sorry, my theory is annoying. Yeah, should like this. If we can see, if we go through this way, from M0 to M5, the maximum speed should be 2.5 Mbps. The same if we go this way. So why we can't reach 2.5 at this part at this time? So you need to figure out why. I will give you a hint. It's about slow start. You need to discover something about the slow start. And yeah, that's all for the exercise 1. So if you have any doubts, please let me know. Okay. So the exercise 2. Understanding IP fragments. In here we have a trace file here. Let me open it. Trace file. Download it and open it. We only want the ICMP package because we are analyzing the ping command, right? So we don't want any other protocol. So just simply apply a filter, ICMP. Oh, doesn't work. Okay. So apply a filter. Then we can analyze how many packets did we send. As you can see, the source IP and the destination IP. The source IP 192 is ourselves, and the destination is the Google server, Google DNS server. Let's have a look. How many packets have we sent? This one is the request, and this one is a response of it. You can see the content of it. It says ping reply, right? So we can consider this one is a pair, and this two is a pair. So how many stuff have we sent? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally we sent 9 packets. Should be the same as here. You can see here we specified the packet amount is 3, right? And we run 3 different commands. The first one is just simply send a ping command, which is 64 bytes to the Google server. And the second line, we send 3 packets of 2000 bytes for each packet. And the step 3, we send 3 ping commands to the Google DNS server. For each packet have 3500 bytes. Then can we check, do they, yeah, they did have this much. So let's have a look of the question 1. Which data sets have caused fragmentation and why? So we had a look, we will need to have a look of the IP protocol here. Have a look at the content. See if we can find anything. It says fragment offset 0, right? Which means it doesn't have any other fragment. Let's see if we can still find other stuff. And the checksum type. Oh, okay. Yeah, we didn't see. And this one should be the same. Let's have a check of the header inside of IP protocol. IP here. Check flags and fragment sets and fragment offset. Here it should be 2000. Let's see if we can find this packet here. Yeah, it says IPv4 fragments 2008 bytes. So why is 2008 bytes? It is because it has a header of IP, right? It should have a header of it. Yeah, but I think need to check after the ICMP package. Let's see if I missed something. Oh yeah, that's the reason why here. We need to have a look of the IPv4 protocol as well, because they have fragmented our ICMP message in here. So that's the reason why I can't see the fragments in here. So you can see here, this one is from our computer to the Google DNS server. And we send a ping command to the server. So what is the size of the fragment? It's 2000, right? Plus the header should be 2008 bytes. And it says we have two payloads from this one and this one. So we can see it have two payloads here. The first one is 1480, the second one is 528. So this part can answer our question. Because the maximum limit should be 1050. See if we can see any information related to that. Fragment offset, no. Okay. So in here we know we have split the packet as two parts. For the packet have 2000 bytes. And let's have a look. How about the 3000 here, 3500? We just find the ICMP packet at the bottom, like this one. You can see the 3508 bytes is split it into three parts. These three, right? So now we know the threshold to cut out packets. Oh yeah, in here we also need to know what is the header length of it. For example here, this 8 bytes, is the ICMP timestamp actually. You can see this 8 bytes is the timestamp of the ICMP. So what is the size of the IP header? Do you still remember? Which I think we have already learned this in our lecture. So what is the size for our IP header? For example, this one, total length 1468. The header length, you can see, we can find out the IP header length is 20 bytes. Right? So just answer this question. So which data size has caused fragmentation and why? You can clearly see these two have caused the fragmented, and you need to specify what is the size of the fragmentation. For example, this one, specify how many fragments do we have, and Yeah, how big for each one? You can click them one by one. Just check the size of it. The length, the headers, like this. Is that okay? And the question 2, did the reply from here also get fragmented? So in here, we know this one is 3,501 by looking at here. So what is the reply from it? This one is the reply, I guess. And this one is also the reply. So can you see the reply of it? Why I know this is the reply of it? Because it's from the IP address of Google DNS to ourselves, right? We just have the look of the IP address, then we can know, oh, is this the reply of it? Is that okay? And give the ID length of the first packet. So we need to figure out what is the first packet sent by this IP address. So in here, we can apply a filter about the IP address. Just find the IP address at first. IP address, right click, apply as a filter, select it. And there are only on this address where we show. Which one is the 3,500? 3,500. Need to find the 3,500 one. Check 3,500. 3,500. Yeah. And this one is still 3,500. How about this one? 2,000. So this one is the packet we want, right? This one. And be aware of the map here. This part. You can see. Can you see the graph here? You can see it already specified these two packets is a part of this one. So we should consider these three as a like one content because our content has been fragmented. So we should consider these three as one stuff and answer the question just by looking at them. Should be easy. Fragments occur when data of size is being used. Why and why not? So just have a look of the Wireshark at first. Yeah, just check by checking the header. Then yeah, you will get the answer of it. Need to check the request we sent and check the response from it. And what will happen if our example 1 fragment of the is lost? What happens if one of the fragment is lost? I think we have already mentioned it on the lecture. So because we are using the TCP link, right? So we can make sure all the fragments will be received by using the acknowledgement and sequence number. So if we only have one packet received, like one fragment has been like dropped or lost in the middle, so we will also drop the other part of it if we can't receive it because we cannot assemble it. So that's all for the question exercise 2. Yes, it will be retransmitted if we can figure if we find any fragment is lost. So it's like, let me try to draw something. It's like we have 3 packets. Sorry, we have packets. And what is 3,500? If we want to send it, we need to split it into 3 parts. Like this. We want to split into 3 parts and then send them separately to our server. And then in the server side, we will reassemble it into the one stuff again. That's how it works. This one, the first one is around 1,500, and the second one is 1,500. Third one is around 500. And once we receive the more, then we can reassemble it. Okay, so this one is for the exercise 2. So don't worry too much because this one is very easy. Just I think this one is the hardest one by finding the correct packet. And yeah, this one, which data size has caused fragmentation and why? In this part, you need to consider the header size of it. You need to consider the size of the packet, like here. This one. So what is the size of the packet? Total size is 3508. Then we have 3 different payloads. 1, 2, 3. And why is only 1480 bytes here? Because we need to because we know the MTU is 1,500 for the packet. So our limitation for the packet size is 1,500, which means for each fragment, the maximum size should not larger than 1,500 bytes. So in here, that's the reason why we sent 1,080 bytes, because we are sending a fragment which is 1500 bytes, since it has a IP header for each fragment. So if that makes sense. So that's the reason it is 1480 here. We need to plus 20 as it has a IP header. So please mention that in your report. Yeah, and yeah, the NTU is this kind of stuff. NTU, maximum transmission unit. The default value is 1500. You can see here, 1500. So that's the reason why it's 1480 here. Plus 20 bytes for the IP header. So it's 1500. Yeah, please mention that in your report. Let me check. Yeah, so that's all we have for the exercise 2. Let me know if you have any doubts. Mm, the next part. Download. Sorry. For the exercise 3, we have a script called TP routing. Just run it. You will find a picture like this. Okay. And just play around with it, and then we can start to answer the question. Which nodes communicate with which other nodes? So by answer this question, we can just simply run the script, and then you will see the answer. Oh, sorry, it's too fast. Just run it. Then you can see which nodes is sending a packet to the outside and what is the destination of it. You can say 0 to which one and 2 to which one. Right? Simple as that. So question 1 should have no problem at all. Just run the script, then you will get the answer. And the step 2, modify the script. So we want to find the line number 84 and 85. Just modify the script by uncommenting the follow to. So we go back to the script, close it, and we need to modify it. Open it. Line 84. I don't know which one is the line 84. Let's open it with Vim. Sorry. And search. What is the name of it again? NS RT model. So we just delete the symbol here and save it and run it again. You can see nothing happened here, which means this part is down. Back to here and slow down speed. You can see this part is down. Right? So we are not able to send any packets from node 1 to node 4 until it return. So that's what have we modified here. These two lines. We set from node 1 to node 4 is down at this time. So they have 0.2 seconds from node 1 to node 2 has been like set to down. And it back online at the second 1.2. So that's what happened. So what happened here, I have already described. That's the rows. Yeah, you can answer that by yourself. And step 4, we need to do some modification. Going to change the line 16 to change the way it find the road. So we back to the script and find the line here. We just delete this symbol and save it. This. So we set this kind of stuff and see how does it work and run the script again. So you can see what happened. Probably it's too fast. I'll replay it. At the time here, you can see because the road from 1 to 4 is down, so they can send the packet from 1 to 2. At this point, you can see we send the packet from 1 to 2 because the road from 1 to 4 is down. That's how it works. So what happened? Just describe it. So you can see with this command in here, it changed the way it finds the road. If we don't have this line, it will just drop the packet at this point at the road node 1. But if we have this kind of setting, we will find another road which is from 1 to 2 and 2 to 3, 3 to 5 to reach our destination. And yeah, go to another question. Just comment the two lines. Which two? 143. This one, sorry. Comment this to, in the question 3, we need to set this to back again and uncomment this one like this and save it. So be aware of we are comment this part in the question 1, I guess, and uncomment this line as is described, just follow the instruction here and rerun it and see the output of it. Then run it. Run. You can see even the like node 1 to node 4 is not down. We are still going from node 0 to 1, 1 to 2, 2 to 3, 3 to 5. Do you know why? In here, we need to have a look of the bandwidth of it and the delay of it. You can see the information are in here. From node 0 to 1, let's open the one. 0 to 1 is 0.3. Let's draw something on this map. Here is 0.3. And then node 1 to 2 is 0.6. 2 to 3 is 0.6. 3 to 5 is 1. 4 to 5 is 0.5. How about 4 to 1? 0.3. So do you know why we go to this road from node 1 to 5? Because it have like faster speed, right? 1, 2, 3, 4. Even we have a higher delay, higher latency, but we will have faster speed. So that's the reason why we choose this part. Yeah, but you can see that actually we had a limitation here, so actually it doesn't really matter. So just describe this kind of stuff in here. And just explain the stuff here. And comment the line 87. So I guess back to the line 87, this line. Comment it and uncomment this two line and save it. Okay, and back to the line 29. Uh, 29 with stuff. Yeah, this one. So we just save it and run the result. Yeah. So you can see the syntax here is we are changing the cost of node 1, node 4 to 2, and node 3, 5 to 3. And that's how it works. So in this one, we are trying to explain how the router find a way to plan the road, send the packet. You can play it by yourself by changing the parameter inside it. You can see we can change the cost for each road. So if we set here, we can try to say if we set from 1 to 4, let's set a very high cost, which means we consider this row is not worth to go, then we can set a very high cost and we can run it. And then you will see there is no packet will go through 1 to 4. Sorry, too fast. Yeah. So you can see there's no packet from node 1 to 4 because we changed the cost of it. So in here, in the question like 3, 4, 5, we are basically playing around with this, and with some other setting in here. So you can do some research by yourself. What does this mean? Just simply put it on the Google and search it. Sorry, this one. Yeah, so it's multipath. What does this multipath means? And what does this one means? Just explain it in your report. So please let me know if you have any doubt. And that's all for our exercise. Yeah, some students may have some question regarding to their assignment. So I will stop the recording here. So you can share your screen or yeah, open your microphone if you want.